Hello everyone, myself Dr. Sonam Gupta and I am working as an associate professor in the Department of Computer Science and Engineering. So today I am going to discuss one complex topic of software engineering, which is risk management. Now, before coming to risk, that what is risk management, how the risk is being managed, what are the various methods to identify the risk, we need to identify that what are the activities in which risk needs to be identified. So, we are having activity planning before any project is started. That project needs to undergo through activity planning. So, it is a part of the project management plan preparation, and we also called it SPMP, which is Software Project Management Plan. Now coming to its objectives, that what are its objectives in the system. So first and foremost objective of it is a feasibility assessment. Second one, it is the resource allocation. Next comes the motivation to the team. After that, the effective utilization of the human resources, then effective time management, project costing, project tracking, and finally comes these are MMM activities. So we can see that the risk activities, these are the last part of the activity planning. We are making it to be the last part since risk is analyzed after all the activities have been planned successfully. Like I have calculated that what are the team members that will work in my team. I know what are the resources that are required to complete the project. Along with it, I also need require about the time management, how the time will be managed, what time will be required to complete this particular project. So for this, after analyzing all these things, the risk will be analyzed. Now next comes the project schedule. So what are the project schedules during which it will be done? So first one, it's having worked out a method of doing the project. So we need a method so that the project can be completed successfully. After that, we need to identify the tasks that are required. So these tasks which are identified, the tasks which will be required to be carried out, these tasks also need to be identified. Then assess the time needed to do each task. I know what are all the tasks that needs to be done to complete the project. After doing that, I need to analyze that what will be the time required to complete each of the activity. And finally, we need to allocate the date and time, that is the start and end of each of the activities. Like suppose I am having 5 activities back to back. Like this is my first activity, activity A, activity B, activity C. Okay, so in the first part, initially what I have done, I have identified that okay, these are the 3 activities in my system which needs to be completed. After that, I need to identify that what activities will be performed when. Like if in this scenario I can see that activity A will be done before activity B. Before activity C can be started, activity B needs to be completed. Okay, so now I had identified the activity network. Along with this, I need to know that how much time will be taken to complete this activity A, because what will be the time, suppose this require about suppose 5 weeks. And now secondly, what will be the time allocated for activity B, suppose 3, and for C let it be 2. So now what will happen, although C require 2 weeks of time, but it has to wait for this 5 plus 3, that means up to 8 weeks to be completed. So C cannot be started till 8 weeks from the starting of the project. So this is the project schedules. Now after project scheduling, how much time will be required, what all things will be done, next comes out to be the risk management. For this risk management, we have some ways of categorizing the risk accordingly, like we are having risk identification, analyzing, planning, monitoring. So these are the 4 most ways to identify the risk. Like risk identification means what are the risk of a project. A project has been started, what all the risk will be acquired by it, what all the risk which we need to take care about. So this is risk identification. Next is risk analysis. Suppose I have identified that okay, 5 risks are there in my project. Second one, in analyzing the risk, I will categorize them in the part like what are the risks which are serious in nature. So which ones are really serious, which risks are really need to be taken care upon, on which risk I have to focus more. So this is the risk analysis. Risk planning, after identifying okay, out of 5 suppose 3 risks are more serious in nature. Now what I have to do about these risks which are more serious in nature? Along with this, how these risks will be managed, how these risks will be tackled upon if this risk actually occur in the project. Next one, risk monitoring. So has the plan work out? So after identifying that what I have to do to overcome that particular risk, so is that planning of overcoming that risk is actually working out or not? So that is the monitoring of the risk. So for that, we look at the PERT risk and then critical change as well. So we are having more definitions of the risk, like it is the chance of exposure to the adverse consequences of the future events. So what are the future events that will happen and what will be the adverse consequences of these risks? So this is the first and foremost definition of the risk. Second one, the project plans have to be based on assumptions. Second keyword which we can identify over here is that assumptions. All the planning that we are doing in a project, that is just purely based on the assumptions. There is no basic facts behind it. Just on the basis of the we can say the experience of the project managers or the experience of the developers, we are making some assumptions, and on the basis of those assumptions the risk has been analyzed. Risk, it is a possibility that assumption is wrong. When the risk happens, it becomes a problem or an issue. So what we can identify that we are just working on the assumptions. So as we all know that assumptions can be wrong as well. So we are having the possibility that assumptions may be wrong. Third one, now if the assumption is right, now suppose if I have identified a risk and that risk actually comes into the picture, so what will happen? So there will be a problem or an issue to complete that particular project. So all these keywords, these needs to be identified during a risk. Now this is the categories of the risk which we can say. We are having actors, structure, task and technology. Now these all, as we can see, all these four are connected to each other, like actors are connected to technology. Similarly, the vice versa, they are connected to the actors. For the task, they are connected to the technology. They are also bidirectional in nature. The structure, it is also bidirectional in nature, and actors. Similarly, actors are also related to task and structure is also related to technology. So we can see that all type of risk, whether the risk will occur at the actor side, that means at the user side, from the technology point of view, from the task related or to the activities which we have identified, or to the structuring, that is to the activity network which we have identified that okay, what all tasks need to be done before and when. So all these things are interconnected in each other. I cannot say that okay, I do not need to identify the risk related to an actor. No, this cannot happen. So we have to see the risk in each and every aspect. Now, what is the framework for dealing with the risk? So, to deal with the risk, we have four framework like risk identification, analysis, planning and monitoring. This four we have discussed earlier as well. Now, we will discuss them in detail. So, first one, it is the risk identification. Risk identification means what all risk can be there in the system, like from A to Z. I will note down all the risks that can occur into the system. This is again purely based on my assumptions. So, what risk might be there in the system, that is risk identification. Next one, risk analysis and prioritization. That means I need to analyze upon all the risks. Suppose as I discussed earlier as well, I have identified that 5 risks are there in my system. Now I will analysis them, that which risks are more serious in nature, which are less likely to occur. So all this analysis has been to be done, and based on the analysis, the prioritization will be done. Okay, that risk will be on priority, this risk will be on priority. So this prioritization has to be done. Risk planning, what are we going to do about them? Like the risk which we have identified over here on the prioritization, what we are going to do for that risk, how I am going to overcome that risk. If that risk occur in the system, then how I am going to deal with it, that comes under risk planning. And finally, the risk monitoring, that is what is the current state of the risk, if it has occurred, how much it has affected the system, or if it has not occurred, that whether it will be likely to occur in the future or it will not occur at all. So this is the part of the risk monitoring, what is the current state of the risk. So this is a basic framework to deal with the risk. Now coming to all these framework one by one. First one, it is a risk identification. So approaches to identify the risk. What are the various approaches to identify the risk? First one, it is the use of the checklist. So basically we make a checklist. That means we note down all the points that can occur in the system. Now the major question which occurs is that from where I am going to get all this checklist, whether some person is going to provide to me, or whether I am having a some set of database from where I can extract that checklist. So basically it is based on the experience of the past projects. So here comes the I can say the experience of the developers, the experience of the project manager, from where they can get that, okay, this project was done earlier as well, or similar type of project has been done. This was the risk which we were encountered. So it is basically purely based on the past experience of the developers. Second one, it is the brainstorming. Brainstorming means getting knowledgeable stakeholders together to pool the concerns. So brainstorming is more or less like group discussions round we can have. We are having various stakeholders in the project. So how those stakeholders are going to affect the project, those people can also share their experiences. They can also tell us about how they are going to work in the project, what are their major concerns. So through brainstorming as well, we can identify that risk. Next one, it is the causal mapping, identifying possible chains of cause and the effect. So when this particular risk will come and how much it will be affected. So that is the causal mapping, from where we can also identify that how the risk will affect. Now there is Baum gave the top 10 development risk. Like what are the type of risk? Personal shortfall. Like personal shortfall is there. So risk reduction technique for this shortfall is staffing with the top talent. The resources which we are going to consume in the project, that is to be going to be the top talent. Next one, job matching. Like suppose I am developing a project in PHP. So the person that is going to develop that particular project should be a master in PhD. No, sorry, a PHP. So that is a job matching. Team building must be there. The persons which are included in the team. So there should be a project manager who can build the team very well. Training and career development, early scheduling of the key personnel. So these are the various factors through which the personal shortfalls can be overcome. Second one, it is the unrealistic time and the cost estimates. Like I know very well that the project is going to be developed in 1 month. But what happens is sometimes due to excessive work or due to pressure from the client, we say, okay, that we are going to complete this project in 15 days. So that is the unrealistic time and the cost estimates. So what are the reduction techniques for it? First one, it is the multiple estimation techniques like design to cost, incremental development, recording and analysis of the past projects. So again and again, we can say that the experience of the past project plays a very critical role in identifying the risk or dealing with the risk. And last one, it is the standardization of the methods which is to be done. Next one, it is developing the wrong software functions. Like the functions which were developed in the software, they are completely wrong in nature. So what we can do, we can have improved software evaluation, formal specification methods, the surveys can be done, prototypes can be developed, and the early user manuals can also be developed for it. Next one, it is developing the wrong user interface. Like by a prototype model, we have not followed that prototype model. We developed an interface, but that interface was not required by the client. So it is developing a wrong interface. What we can do, we can use a prototype model to overcome it. Task analysis can be done. Along with it, user involvement can also be done. Like here, what was the major concern? The major concern here which came upon is that the user was not satisfied by that user interface. Now to overcome from it, we can have the user involvement in the project. So this was the there. Next one, it is the gold plating. So what we need to do for that gold plating? Requirement scrubbing, prototyping and design to the cost. Various other methods have been implemented which was not required. For that, scrubbing methods has to be used. Next one, late changes to the requirements. The user who was supposed to be involved in the project is not able to deliver its requirements completely. So there was late changes. So what can be done? Change control and incremental development model can be used to overcome that particular project. So, in which type of projects this particular issue will come? This will come in the cases where the client is not aware about its requirements. Next one, shortfall in the externally supplied components. So, to overcome this, we can have benchmarking, we can have inspections, the formal inspections, contractual agreements, quality controls, and all these methods. Next one, shortfall in externally performed tasks. So, for that we can have the assurance procedures, competitive designs, better user interface. Next one, real-time performance problem. So, for that performance problem, what we can do? We have a simple solution as a computer engineer, that we perform the simulation first. So, this simulation, prototyping and the tuning according to that particular simulation. Next is development technically too difficult. So, for that technical analysis can be done, cost benefit analysis, CBA can be done, and the training can be given to the developers as well. So, this is the causal mapping that can be done. For that we are having low staff turnover, high. In that we can add upon the experienced staff which is inexperienced. We can also add upon the high productivity. We can add upon the deadlines which were met or deadlines which were missed. The negative will come on the heavy management pressure or low. So, this is the negative side of that particular project that can happen. Uncertain user requirements, this is again a negative point. So, we have mapped it to be the negative side. And the unstable environment, it is unstable in nature. So, it will ultimately lead to uncertain user requirements. So, this is the positive point for leading to the uncertain user requirements. So, this is how this causal mapping can be done. And all the points which are having negative impact, like heavy management pressure, deadline met or missed. So, all these negative points will be taken care upon, so that this risk can be removed. This is how the interventions can be done between the actors, the task and the technologies and the structure. So, as I had discussed it earlier as well, these all are very much related to each other. So, they can handle upon each and every activity. Next comes the risk prioritization. How the risk which we are saying continuously, okay, this is the risk. We will say that this is the maximum priority or list, which is the minimum priority. How this prioritization will be done? So, to identify or to calculate the risk exposure, we have a formula: potential damage multiplied by probability of occurrence. Potential damage means how much that particular risk is able to damage, and probability of occurrence is what is the probability of occurrence that particular risk will happen. Now, let us see an example. We are having an example of potential damage like a value money. For example, a flood would cause about 0.5 millions of damage. So, this is about money. And probability of occurrence, it is like 0.01, so 1 in 100 chance. So, for that the risk exposure will be potential damage, that was 0.5 million multiplied by 0.01. So, this comes out to be 5,000 euros for that particular risk. Now, crudely analogous to the amount needed for a premium. So, accordingly we can calculate the risk exposure. If the risk exposure is high to a certain level, we can prioritize the risk to a higher level. Now, the risk can be prioritized, or the probability is occurred into 4 stages, which is high, significant, moderate and low. So, this is the 4 part in which the risk can be identified. The range, if it is greater than 50% of happening, we can say that the probability of occurrence of the risk is high. If the probability or the range it is 30 to 50%, we say that it is significant in nature. If it is between 10 to 29%, then we can say it is moderate in nature, and if the chance of happening it is less than 10%, then we say that it is low in nature. So, this is how the risk can be exposed. Now, next one, it is the qualitative descriptors on impact of cost and associated range values. First one, like this one, this was based on the range, that is on the probability of happening. Now, next one, this one, it is purely based upon the cost and the associated range values. Like, if it is greater than 30% above budgeted expenditure, what we do during the activities, we calculate the budget as well. Now, if the risk, it accumulates to be 30% above the budgeted level, about the 30% of the activities which were budgeted, we can say that the impact level of occurring that risk is high. Okay, if that level goes from 20 to 29%, we say that it is significant in nature. If the risk level it is from 10 to 19%, then we say it is moderate in nature. And if it lies between 10% of the expenditure, then we can say that it is low in nature. So this is how that risk can be analyzed based on the cost as well. Now this is a probability impact matrix. So we are having a tolerance line and the impact. So what is there? At the x-axis, we are having the probabilities, like we have discussed just now. Probabilities are low, moderate, significant and high. Similarly, on the y-axis, we are having the impact. Again, this impact will be same like low, moderate, significant and high. Okay, now we are having, like suppose in this particular thing we are having 6 type of risks from R1, R2, R3, R4, R5 and R6. Now what will happen based on this, that what is the impact, like R6 is having high impact of occurrence with a moderate probability. So this becomes its first one. Similarly, R2, R3 and R5, they are moderate in nature and they are significant occurring. R4, it is having high in nature and the moderate impact. And R1, it is also high in nature, that is high in probability, and high will be its impact as well. So it has gone to be at the topmost left right corner of the system. So based on it, we will calculate this tolerance line. This tolerance line is again, it is decided based on the experience of the project managers or the developers. So they will identify this tolerance line. All the risk which will be below this particular tolerance line, that will be taken care of easily when we will be making the system. But all the risk that will fall above the tolerance line, that needs to be taken care of before starting the system. So this is the probability impact matrix. Next is the risk planning. So we can risk, it can be deal with risk acceptance, avoidance, reduction, transfer, mitigation or the contingency measures. Now risk reduction leverage. How the risk reduction leverage can be calculated? To calculate this risk reduction leverage, what was the risk exposure before minus risk exposure after divided by the cost of risk reduction. So this is the formula how which we can calculate the reduction leverage. The RE before, this is risk exposure before risk reduction, that what was the exposure of the risk before it was reduced, that is RE before. Similarly, RE after, it means after the risk reduction methods have been applied. What is RE after? Like fire alarm costing 500 euros reduces probability of fire damage to approximately 0.5%. So this is how this after will be calculated. And if this RRL, it is greater than 1, then therefore it was worth doing. If the difference comes out to be greater than 1, that means it was worth that we have applied this particular method. This is again a probability chart which we can develop, like number of days can be given in the x-axis and on the y-axis the probability of the completion. So this is the light grays. So this one, this particular on the 5th, on the 6th, all these light grays, they identify the probability of the occurrence of that risk, and all these dark grey portion like this one, this portion, all these portions, these are the accumulated probability of that particular system. So from here we can calculate the probability, and from that probability the risk can be prioritized. Now next question comes, which we have discussed earlier, that how PERT will be able to calculate the uncertainty. So basically PERT consists of 3 types of time, like M, A and B. What is M? M, it is the most likely time, A, it is the optimistic time, and B is the pessimistic time. In some more books or something, optimistic time can also be represented by O, and this pessimistic time can also be represented by P. So this is how the notation goes on. Now we will calculate the expected time. So to calculate the expected time in PERT, the formula is very simple. A plus 4M plus B divided by 6. Now what is A? A, what is the optimistic time, plus 4 times multiplied by the most likely time plus pessimistic time, and whole divided by 6. This will be the expected time for that particular project. Now we will calculate the activity deviation time, which is S. So the activity deviation time is B minus A. What is B? B is the pessimistic time and A is the optimistic time. So that can also, we can say that P minus O by 6 or this B minus A by 6. One and the same thing, just the difference is in the notations. Now let's see, this is the chain of the activities. We are having task A, B and C. Now for these tasks A, B and C, we are having various values for A, M and B. So we can do this question as well. Now suppose for this activity A, the time required for this optimistic, it is 10, most likely 12 and pessimistic is 16. So what is the question? We have to calculate the expected time. We just have to put the formula, which is A plus 4M plus B divided by 6. So we are able to calculate this expected time. Okay. And for the standard deviation, simply B minus A by 4. So we can have this particular calculations. So these are the answers. You can do these answers at home as well after going through each and every slides. Now assessing the likelihood of meeting a target, that whether a target can be met or not, how we are going to access it. So to assess that particular target, we say that the target for completing, suppose A plus B plus C, it was completely 52 days. Now we will calculate Z for that. The value of Z is T minus T expected. From where this TE will come? This TE will come from that particular PERT activity value divided by S. What is S? S is the standard deviation for that. So similarly, we can have, and the graph of these Z values can be plotted accordingly. For each and every activity, we will have a particular Z value and the probability of not meeting the target percentage as well. It will be given throughout. Next comes Monte Carlo method. So Monte Carlo method, it is again, this is the same for the risk as well. This is the only simulation method for calculating the risk. So it is a numerical method for statistical simulation and it utilizes the sequences of random numbers to perform the simulation. So to calculate a simulation, it performs some random number simulation. Like for this MC simulation, it is a versatile tool to analyze and evaluate the complex measurements, and it is basically to construct a model of a system and experimenting with the model to have to draw the interference of the system behavior. So this is the particular method of the Monte Carlo simulation. This is a simulation model of this Monte Carlo. Like inputs, they are the decisions and the uncontrolled variables. This will be the input to this simulation model, which is the Monte Carlo method, and from their simulation it will give the output. Output will be in the form of the performance or behavior of the system. So this is the benefit of using a Monte Carlo method, that it is purely based on numerical methods. Some simulation will be done and that simulation by or foremost 98% it is having the same results that we were gained in the through simulations. So in the runtime, or we can say in the live environment as well, Monte Carlo, the same risk will be analyzed throughout the project as it was there earlier. Now model inputs, they are capture the environment of the problem for the simulation model. The conceptual model, it is a set of the assumptions that identify the system. Computer code, these are the implementation codes, and the outputs, they describe the various aspects of the system behavior for the throughout the project. There are various types of project constraints as well, like we are having the technical or logical constraints, we are having physical constraints, the activities are there, and the resource constraints are there. So three types of constraints are there. Technical or logic constraints, they are related to the network sequence. Physical constraints, they occur in parallel or they can be affected from the environment as well. Similarly, the resource constraints, they are the absence or storage or the unique interrelationship and interaction characteristics of the resources which require a particular sequencing of the project activities. Now classification, that can be done like the time constraint projects can be classified at a single time, the resource constraint projects, that can be the other type of the project. Now, what is the impact of resource constraint scheduling? there are various effects, like they can reduce the delay, they can increase the criticality, they can also increase the cost, they can also affect the critical path that we identify, the traditional critical path, it can affect that as well. So these are the various impacts of the resource constraining scheduling. Now we assign the resources to the task. So what are the various factors with that? Don't always pick the same set of people for the toughest assignment. We need to change our team regularly. We have to keep an eye on what is the participation of the participants in the project. Along with it, we also need to complement the good habits of the people who are working. We need to motivate them simultaneously. So these are the various resources we have to follow to assign the task. Thank you.